Welcome to the backend walkthrough of LibraryHunter. Our MVP is powered by Supabase, which provides a scalable Postgres database, an integrated API, authentication, and real-time capabilities. In this demo, we will walk through the database schema we built and show how the different tables work together to support real-time occupancy data, NFC check-in and check-out, and personalized study zone recommendations. Here we are in the Supabase dashboard for our project. Under the Database Tables view, we can see the four core tables that power our MVP: users, zones, occupancy, and study sessions. Each table corresponds directly to a major feature of our system. Users represent student accounts. Zones represent study areas in the library. Occupancy holds real-time seat usage numbers. And study sessions records each student's check-in and check-out activity. This structure keeps the system clean and scalable while mapping directly to our front-end flows. We begin with the users table. Each row represents a student. For our demo, we created sample users with fields including the UNI, the student's full name, their school affiliation, and their class year. This table integrates with the SSOL login we simulate on the front end. Once a student logs in, their user ID is used throughout the system to link all their study behavior and personalize their experience. Next, we look at the zones table. Each row represents a specific study area across different library buildings. For example, Quiet Study A, NoCo Cafe seats, Science Collaboration pods, and Tech Lab D. Each zone contains important attributes used in our recommendation engine, including a code naming the location, total seats, the typical noise level, and binary fields for amenities such as outlets, whiteboards, and monitors. These attributes allow us to match student preferences with available study spaces during the recommendation process. The occupancy table stores real-time usage for each study zone. Each record contains the zone ID, a current seat count, and the updated at timestamp. As soon as students check in or check out through an NFC tap, these occupancy numbers update in the table. The front end then reads the latest values to visualize real-time availability. The next table is study sessions, which tracks every active or completed study session. Each row contains the user ID, the zone they entered, the number of seats used when applicable, and the start and end times. The status field shows whether the session is active or completed. When a student taps the NFC tag at the entrance of a zone, a new session is created with a start time and a status of active. When they tap again to check out, the end time is added and the status switches to completed. This drives the active session panel on the dashboard and supports time tracking for analytics or future features like heat maps of zone usage. The schema visualizer gives us a clear picture of how these tables relate. Users link to study sessions through user, id, zones link to both occupancy and study sessions through zone, ID. This relational structure ensures that all real-time calculations and student actions tie back to the correct study zone and user. It also keeps the system modular, so new zones or buildings can be added easily without changing how the rest of the system works. Each part of our front-end application is connected to Supabase through automatically generated REST endpoints. When the student views availability, the app reads the occupancy table. When they request a recommendation, it queries both the zones and occupancy tables, combining zone attributes with real-time capacity. And during NFC check-in, the app performs two things. It inserts a new study, session, and updates the occupancy count for that zone. Because Supabase's API updates instantly, our front end always reflects the most accurate seat availability. In a future production version, we would enable row-level security to ensure that students may only view their own sessions while keeping occupancy public. For this demo, RLS is disabled to make development faster, but Supabase provides built-in policy templates to restrict access or enforce privileges. This allows us to scale the system securely when moving beyond the prototype stage. Together, these tables and relationships form the foundation of the LibraryHunter backend. Supabase allows us to manage real-time occupancy updates, student activity tracking, and recommendation logic, all within a unified platform. This backend pairs seamlessly with our NFC check-in system and front-end web application to deliver a smooth and reliable experience for both students and libraries. Thank you for joining us for this Supabase walkthrough. This backend is fully functional and ready to support the next steps in building a smarter, more efficient study environment on campus.